A current in a long solenoid of radius r and having n turns per unit length is given by I is equal to I sine omega t. The coil having n turns is wound rounded near the center. We have to calculate the induced EMF in the first part, and in the second part the mutual inductance. So in the first part, let's say we have to calculate the induced EMF, that is given by, of course, first we have to calculate the flux that is passing through the center coil. So flux will be given by n phi, that is n times of magnetic field into area. So this capital N is the number of turns on the coil. So I have capital L. Magnetic field, the magnetic field that is at the center of the coil due to the solenoid. Now in the solenoid we know that magnetic field due to a solenoid inside is given by mu naught, number of turns on the solenoid, into current through which it is passing. So magnetic field we have mu naught n I into area, that is pi r square. Fine. So we do have, this is the flux that is passing. On substituting the value of I have n into pi r square into I naught sine omega t. So EMF is given by minus of d phi by dt. If we talk just about magnitude, then it's mod. So I do have d by dt of n into mu naught into small n into pi r square I naught sine of omega t. Now in differentiating d by dt sine omega t, we have cos omega t, because d by dt of sine omega t is equal to cos omega t. So EMF comes out to be n times of mu naught into pi r square into small n into I naught cos of omega t. That is the answer for the first part. In second part, we had to calculate the mutual inductance. We know mutual inductance is given by M is equal to minus E by di by dt. Again, if we talk about just the magnitude, so I have EMF equal to n times of mu naught pi r square into small n into I naught cos omega t, and di by dt, that is I naught sine omega t. On differentiating, I get di by dt as I naught cos omega t. So both of them get cancelled. So I have mutual inductance as n times of mu naught into pi r square into n. That is the answer.